Welcome everyone to Exploring Best Practices for a Greener Kubernetes. This is originally an hour-long talk, so I don't want to waste precious time. You probably all heard of the slogan, reduce, reuse, recycle, which appeared in the 1960s in the conservationist movement as a response to an increased boom in economical boom after the Second World War that created a lot of single-use items, and production was focused on convenience, and a lot of waste came around to be, and the waste was just driven away to landfills. And this slogan was a way to start talking about proper waste management. And with time, those 3 R's became too limiting as the material production complexity started increasing. So in waste management, we talk about the 9 R's, 10 counting from 0, and you can see them on the screen here. And the natural question to ask is, why am I standing here talking to you about waste management on a cloud native conference? And I am doing that because at the CNCF's Technical Advisory Group for Environmental Sustainability, in 2023, we had a project called Sustainable Kubernetes, where we tried finding out practices and ways to think about increasing sustainability, lowering the carbon footprint of Kubernetes clusters from the perspective of individual human Kubernetes operators. And those 9 R's fit quite well with just some modification to Kubernetes. So in the end, we ended up with the 5 R's, 6 counting from 0, of Kubernetes. You can see them here, and this is what the rest of this talk is going to be about. Now, our end goal is that we want to run as few nodes, like machine, as possible, because we generate a lot of waste in the cloud. We want to make sure that we utilize every node as much as possible, because energy proportionality is not a solved problem. There's an interesting white paper from Google about that. And many reports show that in the age of Kubernetes and other abstractions that we love in IT, the potential for cloud waste has only been increasing, because each abstraction layer comes with a utilization cost. And everything I'm talking about here will require, assume you have a autoscaler. So principle number 1, Kyverno was mentioned here in the previous talk, which is great because I don't need to explain what it is. But you can refuse, just as you do for security, you can refuse pods from being scheduled on Kubernetes at all if they don't fulfill certain criteria that would increase resource utilization in your cluster. For example, you can use admission controllers to enforce good practices around setting resource requests and limits, with a caveat that we probably don't want to limit CPUs. Or you want to ensure that if you have a Kubernetes cluster with various workloads, and you probably offer different node pools or machine types for your developers, you want to force developers to choose specific node pools that are best tailored for the workloads. And here we can also and for using Kyverno, for example, you can write policies that enforce using node selectors or node affinity. And this will not work in a case, it doesn't make sense if you have a very simple cluster with just one type of workload and one type of node pool. And we've seen the first talk from Abdel today that setting resource requests and limits is not a do once and then forget forever sort of action. It's something that you have to do. Review regularly. So it is potentially a lot of work, potentially not a lot of work. The next principle is about reducing. So let's say our application was admitted to the cluster successfully. Are we done? Well, no, there are 5 more principles. And reduction is at the core of sustainable architecture. We want to eliminate waste outside of the boundaries of Kubernetes by being selective about the kind of work that we do, the kind of software that we write. We know that the software that is most environmentally friendly is the software that doesn't exist. because we don't need to run it. So it's important to identify work that is unnecessary. And it is important to review your clusters, the workloads running there from time to time, to prevent what we call zombie drift. In Uda, where I work, I did find a service that was running for 3 years, doing absolutely nothing. It was receiving automated software upgrades and was doing absolutely nothing. So this is the kind of zombie drift, this kind of waste, idling waste that we want to get rid of by turning off workloads. We can turn off such workloads permanently. And if we suspect somebody, some workload doesn't deserve to live anymore, we can turn it off quietly. That's called a scream test, and wait for someone to say, hey, I was using that. That is going to work way better than going around and asking, is anybody using this thing? Because then people get reminded and they start getting ideas, and then that service never dies. But you can also turn off workloads from time to time. Few services need to be always on, and anything that's on that doesn't have to be idles and waste resources. And if you probably don't need to run your dev clusters over the weekends. If you do, there's something about maybe work time balance that you should address. But in such cases, employing tools like kubegreen, which can turn off whole namespaces on a simple cron schedule, is going to be the simple hammer that will help you a lot. But if you're thinking about the production cluster, there are tools like event-driven autoscaler like Kida are like a Swiss Army knife that offers a lot more possibilities for scaling down to 0 based on events or cron schedules or anything else. And I unfortunately cannot go into more details, even though I'd love to, for the sake of time. The next principle is about repairing, because even workloads that are running on Kubernetes that are broken, even though they don't maybe serve requests, they still reserve and use some resources. And here we talk about workloads that are visibly broken for Kubernetes and workloads that are invisibly broken for Kubernetes. So first, the ones that are visibly broken. You know, a pod is an image pull back off, crash loop back off, it got killed, and Kubernetes will restart it. And that is a simple mechanism that works some of the time, but oftentimes pods that enter a bad state will still require human intervention. And if you work in an IT organization like me, then you've probably seen pods crash looping for weeks on a dev or staging cluster. It's a waste. It's a waste. So one thing you can do here is use mutating webhooks, which have the capability to scale down workloads to 0 if they're crash looping, and they can scale down to 0 until a human comes and interacts and fixes them. But workloads, sinister is the wrong way. Workloads can also be broken in ways that are not visible to Kubernetes, so they pass all the checks and so on. But they, for example, serve no requests and still use a lot of resources. There are applications that have memory leaks and so on. So here, solving workloads that are invisibly broken, waste resources, requires coming into the boundary of the application and requires knowledge of particular applications. What does it mean for it to behave well or not? And here, it's up to the developers to recognize that and write good, proper alerting to prevent misbehaving applications from wasting resources. So the principle is just as much about being frugal with resources as it is about following good software design principles in general. The next principle is about resizing, or maybe right-sizing. So adjusting capacity as the reality of your workloads, as the reality of the activity on your Kubernetes cluster changes. And you saw a screenshot earlier from CastAI about a report from CastAI about growing waste in the cloud. And CastAI and other organizations recognize different sources of cloud waste. One of them, surprisingly, in 2023, the report was from, still mentions lack of visibility. So we don't know how many resources our Kubernetes clusters actually use. Or we live in the pre-autoscaler era where we still over-provision. And we also understand that classic Kubernetes autoscaling can be a bit slow, so we try to be on the safer side. We don't, what I mentioned already, we leave resources idling, doing nothing. You don't do that to a car. Don't do that on Kubernetes. And we also don't leverage the leftover capacity. That is also much cheaper in the form of spot or preemptible machines that our cloud providers offer us. So one thing we have to do is ensure that we actually know what we measure, because to know what we have, and we do that by measuring, because if we don't know where we are today, we're in the case of resource usage of our clusters, we will not know how we change over time and whether our actions actually do something good or not. And we can either do that using Grafana dashboards, but we can also do that using tools like KubeCost. And this is a screenshot from KubeCost that can not only tell you how much money you pay for different parts of your Kubernetes cluster, but can also recommend compute instance types for your cluster that would be more fitting to the workloads that you run there. And by that, let you utilize the resources better. And from the list, one thing that I haven't mentioned, most of these I've already mentioned before, is the fact that spot nodes, preemptible virtual machines, are a temporary, so a short to medium term solution, because you can run out of spot capacity in a region, which my company experienced, but also they're leftovers, so they're made from spare capacity. If all of us collectively as an industry are more efficient and more frugal, more sustainable with the resources that we use, then with time there will be fewer leftover capacity, and the spot machines will be less available, and then you will have to do other things. And just a caveat, because we often we often equate running cheap with running green, but reserved capacity is one, for example, for a year or longer, is a counterexample that shows that increasing sustainability and decreasing cost don't always go hand in hand, because reserving compute instances for a year or longer, it will provide you with significant discounts, but will prevent you from reducing resource usage when application needs or your company needs change. So this is something to keep in mind. The next principle we talked about and thought we'd like to share is about rescheduling. Rescheduling is about ensuring, like, we cannot predict 100% the load and usage patterns of our cluster, but there are maybe some ways we can even it out in predictable ways. And rescheduling is also about the carbon intensity of the electricity that provides the servers that our workloads run on, and I will explain. Rescheduling is about shifting demands, so shifting our workloads either in time or in space. A practical example, imagine that you wrote your first cron job that starts at every Monday at 3 a.m. and then you write a new cron job. What do? You copy and paste. And suddenly you have 20 cron jobs that all start on Monday at 3 a.m., even though they don't have to. So you can distribute your workloads, scheduled workloads, for example, around the clock based on either the resource usage, so you move them where you know and nothing else is running because, for example, your customers are asleep, or that's the easier version, or you can use external tools like watt time that will give you live information about the carbon intensity of the electricity that your data center cloud provider is running on at this time, and you can use that with Carpenter, for example, to schedule your workloads around the clock. And one of our co-lead of the Sustainable Kubernetes project wrote a master's thesis about how to use Carpenter for that. And there's a link in the slides that I will share later. You can also you can also shift demand in space. So spatial shifting is maybe outside of the boundaries of Kubernetes and more inside of the boundaries of a cloud provider that you use, but it's potentially the most impactful decision you can make. And yeah, there are challenges based on feature parity that might be different between regions or your GDPR limitations. But if you can, you might just by moving your Kubernetes cluster to another cloud region, you can lower its carbon intensity and carbon footprint quite a lot. And here you can use the open source and free cloud carbon footprint application, which you can deploy in your cluster. And it's going to use the billing data from your cloud provider together with its own data to help you show what your cloud carbon cost is, and also where potentially you can make changes. But even without external tools like this, as long as you're running in a single region and all your Kubernetes clusters run in the same region, just looking at resource usage patterns and increasing utilization there will already be enough. And the last quick principle that I wanted to mention today that we thought is worth mentioning is repeat. And I'm sure that many of you already do that, where we identify workloads that don't have to run nonstop, and we run them as scheduled workflows, as jobs on a schedule inside of Kubernetes. And a lot of us do that already from the start when we do database backups, batch jobs, and so on. We don't do that to API servers. I mean, it's so obvious that I still have to mention it. But here, we potentially cut down on idling workloads. If we identify deployments or pods that are running all the time, we identify that, oh yes, this could run actually as a job. But potentially, it might be the transformation of existing workloads might be quite time intensive because it might require changes to code or architecture. So might be something worth considering when planning to deploy new services instead of when writing new ones. And because those 5 areas of Kubernetes are aimed at individual Kubernetes operators, we believe that unfortunately, it's quite unlikely that any of you will have a lot of time. So it's important to give simple starting points for people to consider. And yeah, we add layers of abstraction, like I mentioned, on top of our systems, moving our work further and further away from the material realities that under all those layers of abstractions, we have physical servers running in physical data centers, consuming electricity, water, rare materials, and so on. And just like with waste management, the 9 R's of waste management, they will sometimes limit the material life cycle or like the possibilities of material producers. And I think that's a good thing, something for us to consider, because we as practitioners lack ways of centering environmental sustainability in our everyday work. And if you'd like to know more details, we have a longer version of this talk at the Green Software Foundation Oslo GitHub page. And shout out to Kristina Devočko, who made this talk together with me. And yeah, I am Marta Paciorkowska, and this has been Exploring Practices for a Greener Kubernetes. Thank you so much.